Hi, my name is Jenica, and today I'm going to be swatching and playing with the Aurora Glow Kit from Anastasia Beverly Hills. This was actually the first palette I ever bought, and I saw this at TJ Maxx, and I wasn't super into makeup, but I opened this up and I saw the names, and I bought it for the names of the shades. To start out with, Aurora. I think everybody kind of knows what an aurora is. It's these beautiful curtains of light that you see at the poles. Well, what causes the aurora? Now, it's a complex interaction between the solar wind and the magnetosphere of the Earth. Okay, but what is the solar wind? So the sun is actually constantly putting out particles. Most of these particles are going to be hydrogen because the sun is primarily made of hydrogen, but it can also contain, a considerable amount of other elements like helium, because the sun also has quite a bit of helium. And if you're exposed long enough, you can actually start to see some of the other elements like magnesium. So I say that the sun is constantly putting out hydrogen. Well, what is hydrogen? It is a proton with an electron attached to it. Now, you can have heavier isotopes of hydrogen, like deuterium, which is a proton plus a neutron surrounded by an electron. The hydrogen that the sun is putting out is charged. It's actually missing its electron. So when we say that the sun is putting out hydrogen, we can also say that it's putting out protons. Maybe you haven't heard of the solar wind before, but you've heard of solar flares. Well, you can think of the solar wind as kind of like the wind here on Earth. It's just, always kind of present. Somewhere there is a wind. But a flare is like a hurricane. It is particles with a lot more energy coming at you. This palette contains 6 different highlighters. So I'm going to swatch Helia, which is the yellow one, and Luna, which is the white one first. Helia doesn't really have any scientific basis. Helios is the Greek god associated with the sun, and Helia is the feminine version of that. Luna has a little bit more scientific basis in that, it is a name that is commonly given to our moon in science fiction. Luna, or rather lunar, is used as an adjective to describe things from the moon. I could say a moon rock, but usually when scientists are talking about these kinds of samples, they say lunar sample, or lunar soil, or lunar rock. Luna was also the name of the Soviet missions that were sent to the moon during the Cold War. We normally associate lunar exploration with the Apollo program, but the Soviets also had quite a few successful missions to the moon. They even had some sample return missions that brought back materials from the moon to Earth. The next 2 shades are constellations. So the blue one here is Orion, and then the orange one here is Lyra. So when I'm talking about these 2 shades, I'm going to talk about 2 important stars in these constellations. So for Orion, which is this blue right here, I want to talk about Betelgeuse. Betelgeuse is a red supergiant star, and it's been in the news lately because some scientists believe that it is ready to explode. It's ready to go supernova. Other scientists say that the behavior that makes Betelgeuse look like it's about to explode is due to a lot of dust particles dimming it. Well, when scientists say that something is ready to explode in the sky, when something's ready to go supernova, we're using ready in the astronomical sense. So the universe has been around for, 13, 14 billion years. If we say that something is going to explode in the next 10,000 years, that's nothing on an astronomical timescale. The next shade I'm going to swatch is Lyra. And Lyra is this orange color. And in the constellation Lyra is the star Vega. And Vega is pretty cool because it is actually the first star besides the sun that was photographed. It was also the first star to have its spectrum recorded. Right now, Polaris is the North Star. If you look to Polaris, you know that you're looking north. If you spend all night watching the sky in the northern hemisphere, it'll appear that all the other stars are rotating around Polaris. Now, Earth actually does something called precession. Its axis slightly wobbles. which means that in a couple thousand years, Vega from the constellation Lyra will be the pole star. The next shade up is Eclipse, and this one's right here. And it looks very similar to Lyra in the pan, but when you swatch it, it's actually pinker. And you can really tell that when I'm swatching. So it's not orange, it really is this whitish pink. You're probably very familiar with lunar and solar eclipses. For a solar eclipse, that means that the moon is coming between the sun and the earth and blocking out some of the sun's light. And there's a small region on Earth that will go dark because it's being blocked by the moon. Now, the Earth is a lot bigger than the moon, so when the Earth gets between the sun and the moon, all of the moon goes dark. There's another kind of eclipse that's really important for science. When we're looking at other stars, their planets are eclipsing those stars. We can actually use that phenomenon to figure out how big the planet is, what its atmosphere might be made of. So it's really important for us to watch for these eclipses of exoplanets around their host stars. The next shade, and the last shade I'm going to swatch, is Spectra. And it is this purple color. And it looks really dramatic when it's in the pan and when it's swatched. But I actually, when I'm looking for a highlight out of this palette, I do tend to go for Spectra and Orion just because they are so different. And using these two shades is really great if you're going for a monochromatic look. So if I want to do kind of a pinkish purple eye look like I have today, then this is the highlighter that I'm going to use. And one thing about these highlighters is that they are pretty glittery. So if you like a shimmery highlight, and I usually do, then this palette really isn't for you. But you can see that I do get just this slight purple pink sheen, and it really is pretty subtle. You know, when I'm looking at this palette, I think, you know, Spectra, that's just kind of a weird thing to put in with Luna, Orion, Lyra. We're all thinking of, like, you know, the night sky, and then you have Spectra. Now, that's one of the things I love about this palette, because Spectra is the plural form of spectrum, and there are so many important spectra in science. So I'm going to talk about two today. When we describe something, a lot of times we can define it in binary terms or with a number, but a spectrum is something that is continuous. So let's take, for example, the electromagnetic spectrum. The electromagnetic spectrum describes a range of energies or frequencies in photons. We most commonly see the electromagnetic spectrum in terms of the visible light. When we look at all the different colors, we're looking at different energies of light. Now, perhaps you've heard of X-rays or radio waves, microwaves, UV light, infrared light. These are all the exact same thing as normal visible light, but it just has a different energy. It's either more energetic or less energetic, but it's just the energy of the photon that you're interested in. Now, when we look at stars, we can use these spectra. We can use what the electromagnetic spectrum of that star looks like in order to determine a lot of the properties of the star, because that is one thing that stars do. They emit light, and we can measure that light and we can determine a star's properties. There's another set of spectra that are really important to science, and that is the mass spectrum. For me, in my work, I use this very frequently. If I want to figure out what is in an object, most of the instruments that we use will give this information to us in some mass spectrum. And a lot of the scientific work that we do is disentangling all the information just from looking at how much material is from this mass range. There are a bunch of different instruments that'll give this information to you in slightly different ways. And in order to get the full picture, we need to go to each one of these instruments so we can fully understand our material. So if you're a sucker for science-themed makeup, then I recommend this palette. Also, if you happen to be pretty adventurous in your highlighter choice, I also recommend this palette. I hope you learned something about some of these objects and these terms. Thanks for watching. Bye.